Good morning, all. Hi. Let's see what's an algorithm, pseudocode, and flowchart in this session. What's an algorithm? So, algorithm is a step-by-step method for solving a problem or doing a task. An algorithm need to have an input and it should give us an output. It's a sequence of steps which helps us to give a solution to a specific problem. Algorithm, a procedure, or a method for solving a problem. It provides a scheme or a solution to a particular problem in a finite number of ambiguous steps, unambiguous steps. Algorithm helps us implementing the solution of a problem using any of the programming languages. Algorithm is a sequence of steps, a method of writing steps in sequence in an order. When we think of solving a problem, when we think of getting a solution to a problem, we write a sequence of steps how the problem can be solved, how we can go for getting a result to a problem. And those sequence of steps which helps us to solve a problem can be called as an algorithm. They can be called, I'm not saying it is an algorithm, they can be called as an algorithm. So when we think of an algorithm, it's a method, it's a procedure, it's a way where steps are written in sequence in an order to get a solution to a problem, to define a solution to a problem. That's what an algorithm is. It provides a solution to a problem. And when we think of an algorithm, it should end in a finite number of unambiguous steps. It should end at somewhere. It should end and it should give us an output. Then those sequence of steps, then those number of steps, then the method we adopted to write the steps in sequence, we call it as an algorithm. So an algorithm is a sequence of steps. An algorithm is a method to get a solution to a specific problem in a finite number of unambiguous steps. Unambiguous, where every step is clear, precisely gives a meaning what that particular step does in getting a solution to our problem. It helps for implementing the solution of any of the given problems using any of the programming languages, any of the programming syntax. Once we know how to write an algorithm, it clearly defines the way how we can go for getting a solution to our problem so that I can go for coding using any of the programming languages. So when I said algorithm is a sequence of steps, algorithm is a method of getting a solution by writing the steps in order to get a solution to my problem or our problem. Then whatever I write in sequence, whatever the steps I write in sequence, whatever the method I adopt, writing the steps in order, does it makes an algorithm? Does it can be called as an algorithm? No. Algorithm should possess some properties. It should possess some. So if at all whatever we write in steps, it is called as an algorithm? No, never. To say it as an algorithm, to call it as an algorithm, to qualify it as an algorithm, The sequence of steps, whatever we write, should possess some properties. What are those properties? So don't think that when I get a problem, I write some sequence of steps, and those sequence of steps is called as an algorithm. No, those sequence of steps need to possess some properties, and those properties, if at all, a specific method, or a specific sequence of steps, if those properties are possessed by it, or then it can be called as an algorithm. So what are those specific properties which an algorithm need to possess? Number one, every algorithm need to end in a finite number of steps. Algorithm shouldn't be infinite. Algorithm should end it in a specific number of steps for a specific problem. That's what we call finite number. It should terminate at one point. It should end at one point. If my algorithm is not ending, the sequence of steps what I am writing to get a solution to my problem, if they don't have an end, then it is not called an algorithm. It cannot be called as an algorithm. My algorithm need to end and it should give me an answer, a result. Then it can be called as an algorithm. Next, every algorithm need to have definiteness in it. Each step, as I told you, each step of the algorithm should have a clear meaning. It should be precisely defined. It should have some sense in the step. It shouldn't be ambiguous, confusing, messy statement. It should be a clear statement which defines what the statement is and what for the statement is used. It should make it as sense, and that's the one of the property of algorithm, that is the definiteness. And then algorithm may have zero or more inputs. When I say input, input can be a static input, or a dynamic input. When I say static input, when I write the algorithm, when I write the algorithm, in the algorithm itself, I go for giving the values which are required to get a solution to my problem. That's where I say they are the static inputs. And I say if at all I give static inputs, maybe zero inputs. And when I say dynamic input, when I look at running of the algorithm, when I execute the algorithm, I give the values when I'm executing the algorithm. Then I call them as the dynamic inputs. So whatever may be the input, may have an input, may not have an input. If have an inputs, can be zero or more inputs. And they are which need to be given or initialized before the algorithm execution starts. They are the initial things which are supposed to be given for an algorithm. So algorithm should have an input, then every algorithm, so whichever the steps, whatever the steps we are writing in order, when we think of a problem and write some steps, and those steps and that method, it should give me an output. If at all I am writing some sequence of steps without getting a solution, without getting an output, it's not called an algorithm. When I think of writing an algorithm, I should have an input, I should have an output, and it should possess some definiteness. That means every step of the algorithm need to be clearly specified, and it should end in a number of steps. Maybe number of steps can be 2 steps, 3 steps, or 4 steps. One algorithm can end in 5 steps. One algorithm can end in 10 steps. One algorithm can go for ending in 100 steps. But it should end at some point. It should have a termination. That's what I am saying. Okay? Then it's called as an algorithm. And we have the one more property of the algorithm, that is the effectiveness. Effectiveness means all the operations of the algorithm should have a finite length of time. They must be done perfectly. Every statement should have a length of time. That means the evaluation, the expressions evaluation need to have the perfection in it. That's what we call the effectiveness of an algorithm. We write an algorithm, we write a step, but that step doesn't give the result, effective result. That step doesn't function giving us a better result. Then it is not an effective step. When there is no effectiveness, then it can't be called as an algorithm. Then last property of the algorithm, as we already know it, that is the end of the algorithm, termination of the algorithm. After the algorithm gets executed, the user should get the desired result, and there the algorithm need to end. If my algorithm is not ending, then it is not an algorithm. That's where the properties define finiteness and termination. It should have a finite number of steps, some number of steps to give a solution. When it has a some number of steps, definitely it need to end at some point. There should be a termination for the algorithm. So whatever the steps we write in sequence, the method we adopt of writing the steps in sequence to get a solution to our problem, to get an answer or a result to our problem, possessing all these properties: finiteness, definiteness, input, output, effectiveness, and termination, then those steps, that method is called an algorithm. Now it might be clear to every one of you that writing anything in sequence is not an algorithm. Writing steps in order is not an algorithm. What is an algorithm? Algorithm should have finiteness. Algorithm should have definiteness. Algorithm should have input, output, effectiveness, and termination. So these sequence of steps are a method which possess all these properties, giving us a result to our problem. Then we call it as an algorithm. An algorithm, when we think a method or a sequence of steps as an algorithm, the algorithm can give us the solution, can give us a desired result, can produce an output exhibiting three features. It exhibits three features: how my algorithm execution takes, how my algorithm goes to give me an answer, to give me a desired result. That's what we call the features of an algorithm. What are the features every algorithm can exhibit? An algorithm can go for exhibiting all the three features. An algorithm can go for exhibiting any one of the feature. It can be any one of the feature, but it exhibits these three features. What are those features? When we think of the features of an algorithm, they exhibit the sequence. One of the feature is sequence. That means, as we already defined, algorithm is something which goes in sequence. Algorithm is something which moves in sequence. That's what we already see in sequence. Sequence means that each step of the algorithm is executed in order, in a specified order, or in sequence. That's what we call it as an one of the feature. All the algorithms may not give us solution only executing in sequence. They may execute as per the flow of the control. So the control of the flow of the steps, we are calling them as the features of the algorithm. The sequence means all the steps going in a specified order. It doesn't mean they need to go only one after the two, two after three, three after four. No, they can go in any sequence specified order, in a specified order. Then decision. Decision statements are used when the outcome of the process depends on some condition. My algorithm, my step, I write somewhere at one step. If I write it like this, if x greater than 0, it need to do something greater than 0. I ask x is positive. I ask to display x is positive. X is positive. X is positive. If x is less than 0, I say print x is negative. But the steps doesn't fall in sequence. The steps can go on falling based on the condition. They can jump, or the flow of the step can be brought from one step to the another step, can be shifted from one step to the another step based on the condition. So my algorithm can exhibit a feature that is the decision, a condition based feature. And it can also exhibit one more feature that is a repetition. Sometimes one step of my algorithm wants to repeat it for more than once. Maybe one step of my algorithm must be repeated three times, four times. If I do any step of the algorithm repeating for more than once, then I call it as a repetition. Repetition of these steps. So all the algorithms, any algorithm definitely possess or exhibits any one of the feature at least, and it can even exhibits all the three features in one algorithm. One algorithm can go for exhibiting all the three features. One algorithm can go for exhibiting any one of the feature at least. So that these are the features which all our algorithms exhibits. So when we are writing an algorithm, think and keep always in mind they should have some properties. Algorithm should possess some properties. So when we are making our algorithm to possess some properties, definitely every algorithm, whatever we write, exhibits these features. Sequence, going the algorithm in sequence, going the algorithm on decision based, condition based, and going the algorithm in repetition. Let's see an example of an algorithm to compute the area of a rectangle. And before I start writing the algorithm, area of a rectangle, I'd like to tell you one more very important thing. Whenever we go for writing an algorithm, remember, as always remember, algorithm need to start with a command, with a statement, always with start. Remember this, it's mandate. When we write the algorithms, every algorithm should start with a statement or a command start, and then follows the steps required or the statements required to get a solution to my problem. And then at the end, nth step, I require to write the stop or end. My algorithm need to have an end. It should possess a start, it should possess an end, and in between I have the steps to be written to get a solution to my problem. That's what the algorithm is. And my algorithm can go for having two steps or three steps or four steps or five steps. But the last step is an end step. And the first step is start. So let's start writing an algorithm to compute the area of a rectangle. Before we write, we just think what the problem is, what the result is expected from us. Area of a rectangle. When I think of writing the algorithm for an area of a rectangle, what all I need to calculate the area of a rectangle is to be taught. And what all I need is, if at all I think here, to calculate the area of a rectangle, I need L, I need B. Why? Because I know area of a rectangle will be calculated as L into B, length into breadth. So I need L, L is nothing but length and B is nothing but breadth. So for calculating the area of a rectangle, the things which are required, the input which is required is L, and the other input which is required is B. And then computation need to be done, that is area. Area need to be computed. So thinking this in mind, I just go for writing an algorithm, starting with a step number one, that is start. Then, to compute the area of a rectangle, the minimum requirement or the minimum inputs what I need is L and B. So I go for saying input L comma B, or even it need not to be only input. It is only a statement. You can go for writing read A comma B, no issues. You can write read A comma B, doesn't matter. You need to understand what is A, what is B. A is length, B is breadth. Or read L comma B to make it more sense, to read L comma B. What is L comma B? L is length, B is breadth. And then when we have the inputs, when we have the input length and breadth, what I am supposed to do? I am supposed to calculate or compute area, calculate or compute area. What I am doing is area equal to L into B. That's what I did, area equal to L into B. What does this statement gives? This statement is computing the area for a rectangle, computing the area for a rectangle, calculating the area for a rectangle. And after calculating the area of a rectangle, see my algorithm, it has started, it has taken two inputs, it needs two inputs, it has taken two inputs. Then after taking the input, the computation of the area is done using the mathematical formula, that is area equal to L into B. And after calculating the area, what's the next step? My algorithm need to give the result to the user. Result to the user. So result is displayed or given to the user using a command or using a statement display, or you can even write show area or print area, no issues. It is only an algorithm, it doesn't have any specific words to be used, it doesn't have this specific terminology. It's only a sequence of steps giving us a solution to a problem in a finite number of steps with some definiteness, with input, output, and end at some point. That's what the algorithm is. So I can write show area, or I can write print area. Anything is right. Then I displayed the area to the user. Then after displaying, so my solution is now to get the area of a rectangle. I got the area from step number 2 to step number 4. I got the area. Reading LB, computing the area and displaying the area. My solution is out, but if at all I stop here, it is not a perfect algorithm. Every algorithm need to start with the command start or the step start, and as I told you, it need to end with the step stop or end. So my next step of my algorithm to find the rectangle, area of a rectangle is stop. Now this algorithm from step number 1 to step number 5 gives me a solution to find the area of a rectangle. So this algorithm now, the steps written here to get a solution to find the area of a rectangle is called as an algorithm because it has definiteness, it has finiteness, it has an input, it has output, and it is ending at some point. That is the termination. Possessing all these properties, if we write a sequence of steps to get a solution to a problem, then we call it as an algorithm. Without possessing those properties, even we write n number of steps, it's not called an algorithm. So what is an algorithm? A sequence of steps written to get a solution to a problem possessing the properties of the algorithm. We call it as an algorithm. Then an algorithm to compute the area of a square. You can practice, you can try to write an algorithm to find the area of a square. Taking the example of the above. What is required to find the area of a square? I require side of the square. So first step I need to write something, and then I have the body of the algorithm to find the area of the square. Then the nth step or the last step I'll have stop or end. You can think of it. Start, and in between I have the body of the algorithm which makes me to calculate the area of the square. So our algorithm starts with start, then I need an input to calculate the area of a square. So that input is side of the square. Side of the square. What is the formula to find the area of a square? That is s into s. So I need the side of a square. So I say input yes, or I can go for writing here read yes, read yes, or in the simplest way, if at all you want to make, for me, it doesn't matter if at all you write take yes, but think that input or read yes is a better terminology to write a statement over there. Input yes, then input yes, the required input to get the solution is yes site, and after getting the site, the formula or the computation or the mathematical expression need to be evaluated, and that evaluation is done here. Expression is executed, and the expression evaluation is area equal to s into s, side into side, and my calculation to find the area of a square is done. And after getting the solution, and this solution area need to be displayed to the user. To get it displayed, the command or the statement to be written in the algorithm is display area or show area or print area. It can be display area or show area or print area. Show area or print area. Okay, and once the solution is derived, the last property of the algorithm is to have an end to an algorithm. So my next step is going to be stop. My algorithm has come to end and started with the starting command and ended with the stop command, and I have in between three statements or the three steps written in sequence, one after the other, where each statement has a precise meaning, and it is giving us an output, taking an input as in a fixed number of steps, in a finite number of steps with a termination. Then I call this is an algorithm. It is an algorithm, a perfect algorithm. So here are the two examples which I shown you to define what is an algorithm. So once again, I repeat, an algorithm is a sequence of steps which gives us a solution to a specific problem, possessing the properties of definiteness, finiteness, input, output, effectiveness, and termination. An algorithm even exhibits, any algorithm exhibits any one of the three features. They are sequence of execution, conditional based execution, what we call it as a decision, and the last one is repetition of steps. Repetition of steps. And moving ahead, we know what is an algorithm. And after knowing an algorithm, let's even know what is a pseudocode. And pseudocode is in between writing an algorithm and writing a programming code using a specific programming language. In between algorithm and writing the code in a programming language is pseudocode. So, what exactly a pseudocode is? A pseudocode is an informal way of defining programming that does not require any strict rules of the programming language. A pseudocode is something looks like an algorithm, but it's not an algorithm. It's not exactly the program. In between an algorithm and a program, it gives a solution to our problem without following any of the syntaxes. It doesn't have any syntax. When we move to a programming language, every language says you are supposed to use this. You are supposed to use this, a semicolon to end, a keyword to define something, and header file to define something, and such kind of restrictions will not be in writing a pseudocode. That's the reason why we are calling a pseudocode is an informal way of programming description. It what we are supposed to do in program is defined in pseudocode, which looks like an algorithm, but it's not an algorithm because it doesn't have any strict rules, strict conditions to be followed. So it is used for creating or to know a rough draft of a program. That means how our program need to be solved, how we can go for getting a solution to a problem is written without any strict rules or the syntaxes. When we write those steps in order, which informally defines the way of solving a problem or the way of getting a solution to a problem, that's we are calling it as a pseudocode. And let's look at, we have known the algorithm. If at all you look at the pseudocode for the same algorithm, you will be able to know how varied is pseudocode from the algorithm. So let's see the example of pseudocode for calculating the area of a rectangle. Step, nowhere it is being instructed, but I always tell you one thing. For writing the pseudocode, also at least to adopt, to make ourselves more conscious of getting a solution to our problem, I always say you start even writing the pseudocode with the steps, in steps, with starting with a start or initialize statement, and then start or initialize a statement, and then to have at the end to have completed or finished. Or if at all you write stop, also no issues, but stop is nowhere used because we are just defining how we can go for solving, getting a solution to our problem. That's what in pseudocode we do. So start, and when we want to calculate the area of a rectangle, what are needed in the algorithm? I say input L and B, but here you can go for saying, I am not saying the L and B. I'm briefly just defining what is needed to get the solution. There in algorithm, specifically I mentioned inputs, that is L and B. In pseudocode, what is needed for my problem to get the solution is specific. What is needed? I need the sides of the rectangle. That's what. And in algorithm, the sides of the rectangle are specified as L into B. That means I need the length and breadth. I need the length and the breadth. There I said input L comma B. But here I am saying input sides of the rectangle. So what are those sites? I have not specifically precisely mentioned, precisely defined, but still I know how the problem need to be solved. How the problem can be solved is written in steps. That's what an informal way of defining a solution to a problem without following any strict rules. We are calling it as a pseudocode. Then after getting the sides, what I do, I need to compute the area of the rectangle. How I compute, I am not mentioning. See here, how I compute is not mentioned. The next step is you take two sides of the rectangle, then compute the area of a rectangle. How the computation is done, how I can go for getting the result, what is the formula is not mentioned over here. Only the step is mentioned, what I am supposed to do next. What I am supposed to do next, when I go for getting the sides of a rectangle, I am supposed to calculate the area of a rectangle. So compute the area of a rectangle. And after computing, the next step is show that result or give that result to the user or display that result to the user, and that step is mentioned. And these are the three steps which are making me to think and analyze to get the result to my problem, that is to find the area of a rectangle. Input the sides of a rectangle, find as compute the area of a rectangle, then display the area. And after displaying the area, the last step in my pseudocode is finish or completed. My problem solving is finished. My problem has got a solution. After getting the solution, my writing of steps, how I need to get a solution to my problem is defined here. How I need to get a solution to my problem is defined from step number 1 to step number 5. What is that? You start solving a problem, that is started with a starting command, and get what is required for your problem. That's what I got it, sides of the rectangle. And what after getting the sides of the rectangle, what you are supposed to do, calculate the area of a rectangle. Calculated, once if it is calculated, give that area of rectangle to the user or the programmer, give it, and then complete the execution, or the problem has completed, it has come to an end, representing with a completed symbol. This is what the pseudocode is. Maybe it doesn't have any properties, it doesn't have any properties. I'm not saying it possesses some properties. No, I just written something in sequence. So if at all you say now, if at all I write an algorithm without possessing anything like effectiveness, definiteness, finiteness, termination, can it be a pseudocode? No, not exactly. Our pseudocode also need to have an ending with a result, because it is an informal way of defining a solution to our problem, uh, as other than the programming language constructs. That's what a pseudocode is. So next, moving to, we have come to know what is an algorithm and a pseudocode, and next we move to the flowchart. What is a flowchart? You may go for asking me a question, why do we need to write an algorithm and draw a flowchart, have a knowledge of writing a pseudocode? For a good programmer, it is mandate to have a practice of writing algorithms and drawing flowcharts, even the pseudocodes. Before we write the code in the programming language, we can have on a paper how the problem can be solved. We can have analysis of the problem, we can analyze the problem, and how the problem can be solved can be written in terms of an algorithm, in terms of a pseudocode, can be drawn in terms of a flowchart, which gives a clear picture to ourselves how the problem can be solved, how a problem can get a solution. So moving ahead, a flowchart is a graphical or symbolic representation of an algorithm in a single statement. A visualization of our algorithm is a flowchart. If at all I show my algorithm visually with some symbols, then it is called as an algorithm. It is called as an flowchart. used to design, develop a complex programs to help the users to visualize the logic of the program. Why the flowchart is used? To help the users to easily understand how the problem is solved looking at the picture, because the example which I have taken here is only finding the area of a rectangle, which has finished in 5 steps or 6 steps. But if at all I write an algorithm which has 100 lines of steps, 100 steps, can you go for understanding what the algorithm is with a single glance? No. But if the same algorithm is shown as a picture using some graphical representation, you will be able to understand what the flow of the problem is, how the flow of the problem is going on, how you can go for getting a solution to your problem. That's made easy using flowcharts. So all the steps of our algorithm, to say in a simplest way, the steps of an algorithm are visualized, are shown visually, are depicted using some symbols to show the flow of the program is called a flow chart. So a flow chart is a graphical or a symbolic representation of an algorithm. So when we think of a flow chart, what kind of symbols we use? What are the basic graphical symbols used for showing the solution of a problem? So here comes the symbols which we use to show the process of a flow chart. You can go for seeing one symbol here on the top. It is a rectangle symbol which is used for processing. When I say compute the area, some process need to be done. When I say calculate the area of a square, some processing need to be done. Then such kind of processes, all the statements execution, we go for using the symbol, this symbol that is a rectangle symbol. And in the similar way, when you look at your algorithm has an input and an output. So using flowchart, if at all you want to represent where you are giving input and to know from which is the output, to define or to depict an input or output, we use a symbol here, parallelogram. It is an input output symbol. So same algorithm can be written using these steps, using these symbols, making it as a flowchart. So next we have one more symbol here. As I said, algorithm can have a decision. Even flowchart can even go for having a decision, because already we know that flowchart is nothing but diagrammatical representation of an algorithm. So whenever we want to represent a condition or whenever we want to go for making a decision, a condition, checking of a condition, we use the symbol diamond symbol or a rhombus symbol. We call it as a rhombus or even we call it as a diamond symbol. Decision box. We call it as a decision box. So decision box can be used. Then next, our flowchart or the algorithm cannot go for finishing in a single on a single page without, maybe sometimes our steps need to be repeated. So the flow of the problem need to go back, come forward, move ahead without intersection of the other things, maybe without intersecting the previous symbols which are used in our flowchart. In such a case, we have the off connector or the flow connector, which allows us to join or interconnect the symbols without intersecting. We call it as a circle. It's a circle. And then moving ahead, we have one more symbol here that is a predefined process symbol where if at all we use some statements, predefined statements need to be executed as a part of our algorithm, and which can be represented using a flow chart, then we use a predefined process symbol. And this, if when we go to the functions or when we know what is our subroutine, then we can go for making use of this. So when we move ahead and when we make use of the subroutines, definitely I'll draw a flowchart and I'll show you how this subroutine is used in the implementation of the flowchart. Then coming to the next symbol, that is a terminal or the oval shape symbol, which is used for starting and ending representation of a flowchart. To start a flowchart, to end a flowchart, we use the symbol, oval symbol, that is the terminal symbol. As I said in an algorithm, it starts with a start command, it ends with an end command or the stop command. Similarly, flowchart also need to start with a start and it should end with stop or end. And those statements are represented using the terminal symbol or a oval shape symbol. And next coming to down, we have one more important symbol, that is arrow marks. They are the arrow marks. Flow lines. In algorithm, we made it to look as a sequence of steps: step number 1, step number 2, step number 3, step number 4, step number 5, step number 6, end. We got it. So I understood that these are the steps which need to flow in one after the other. Then in a flow chart, how do I understand how my algorithm, how my flow chart is moving or flowing, how the control of my problem is going on? So my control flow or the flow of my problem will be represented using the arrow symbols, arrow lines, or we call them as the flow lines. The connecting of a symbol to another symbol is done using the arrows or the flow lines. So these are the basic symbols or the graphical representations which we use to draw the flow charts. So let's start with an example of drawing a flowchart to add two numbers. I'm depicting the flowcharts or the algorithms only taking the very basic examples, but it is very easy for you to understand. If you understand the basics, you can do it to any of the complex problem. Draw a flowchart to add two numbers. So when I think of drawing of a flowchart to add two numbers, if at all, before drawing the flowchart, I can go for writing an algorithm. What do I need to add two numbers? One step, I need start. Can you say I need a start? Then maybe adding of two numbers, then the last step or nth step, I need stop. What all the steps I need in between to complete or to get a solution to a problem, that is addition of two numbers, add of two numbers. Maybe second step, what is the step? I need two numbers. I need two numbers. In the similar flow, I just go for showing you the flow chart here. Now, I need two numbers. Maybe input A comma B. Yes, I need two numbers. Then third, I need to calculate the sum of two numbers, C equal to A plus B. And after calculating the sum of two numbers, I need to mention as print or show or display. Anything is okay. Print or show or display. I say display C. So output is given to the user. This is how I write the algorithm. And the same algorithm I need to depict using or visualize using the graphical representations. So let's see the flowchart. Let's see the flowchart. So I have the flowchart here, start. I have the flowchart here, start, and then I have the inputting yes, input of two numbers. You can see here, I have the flowchart here, start, and we have the start in the algorithm. Then have the input of two numbers, that is read or input number one and number two. Number one and number two, two numbers are given to the flowchart, and then have the calculator or the computing part. computational part, that is sum equal to number 1 plus number 2, or a plus b, where c equal to a plus b, and then I need to print the result to the user, that is print sum, and then my flowchart comes to an end with a symbol end. You can look at start. My first step is start of the algorithm, and second step is reading of two values, and third step is computing the sum of two numbers, and fourth step is giving the output to the user, and fifth step is ending of the algorithm. The same algorithm is shown using pictures from top to bottom to get a solution to my problem, that is adding of two numbers. Adding of two numbers. So what the symbols I used here is the terminal symbol. This is the terminal symbol, and this is the parallelogram, which is used for inputting the values or reading the values from the user, and this is a rectangle box used for calculations, used for processing things. And again the same output or input box is used here, parallelogram. Then I have used another symbol, that is a terminal or the oval shape, to indicate that my flow chart has come to an end. So this is how we go for drawing the flow charts to represent our problems, solutions of our problems in a graphical way, in a pictorial representation. Okay, then let's move ahead. Draw a flowchart that will read two sides of a rectangle and calculate its area. The same example of our algorithm is taken over here. So let's see what the flowchart is going to be. And this is the flowchart. Start. What all I need? I need to start. The first step of my algorithm is start. The same thing is represented using a picture. And the second step of my algorithm is read or input width and length. That's what the input box is taking. And the third step of algorithm is calculate area, where area equal to L into W, width and length. And then print area, fourth step of the algorithm is display or print area to the user, or display area it is given. And the last step of the algorithm is stop. The same algorithm used with some symbols represented over here, a terminal, and input output box, a process box, and output box or the input box, and then we have a terminal here. And this is how a flow chart is representing the algorithm in a graphical way is called as an algorithm, is called as an, sorry, is called as a flow chart. So let's write an algorithm and draw a flowchart to find the greatest among two numbers. Here comes a point where my algorithm is not going to flow in sequence. My algorithm is going to flow with some condition. My algorithm or my flowchart moves with some condition. So that's where I'm going to show you the flowchart. Look at the flowchart. Start. My flowchart starts with an algorithm step start, and then I read two values A and B. I can go for writing the algorithm here. I am writing the algorithm towards the side start. Step 1 and step 2 is input or read, input A comma B. I am reading the two inputs, and then coming to the third step. See here, there is a condition. Look at, if A is greater than B, my solution is to find the greatest of two numbers. Then third step of my algorithm need to be as if A is greater than B. If A is greater than B, what should I do? If what should I do? If A is greater than B, what should I do? It should display A is great. Yes or no? Yes. So in the flowchart also you see, if A is greater than B, true. If A is greater than B, true. Then it is saying display A. That means A is great. If A is not greater than B, see here it is going towards the false side and it displays B. That means if we are comparing, if a comparison is done among two, if one is not great, ultimately the other one is going to be great. Then display B. And after displaying any one of these results, it need to come to an end statement. That's what the flow chart is. In the similar way, our even the algorithm is also. If A is greater than B, what need I to say? Yes, I say go to, I'm writing an algorithm statement. Go to, this is step number 1, step number 2, step number 3. Don't get it confused. I'm writing step number 4 is display A. Display A. If A is greater than B, go to, this statement need to be written. I'll say go to 4. This is step number 3. I'm asking it to go to 4. Go to 4. Yes. If A is not greater than B, if A is not greater than B, where it should go? Where it should go? Tell me. As it should go to somewhere else, which step? Checking that printing display B, display B. And then if after displaying B, see here, after displaying A, it should go to, I'm shifting the control, go to last step. What is that? End. End. Now, step number 1, step number 2, this is step number 3, step number 4 is this, and step number 5 is this, and step number 6 is this. Think that now 1, 2, 3, if A is greater than B, go to 4. Which step it need to go to 4? Where is go? 4 is display A. After displaying, again it should not go to this step, because B is not going to be the answer. Only the A is going to be the answer. So after displaying A, it should go to 6 directly. That means my problem need to end. So after displaying here A, my problem need to end, come to an end. Again, it need not to print B. It is not supposed to print B. It's only supposed to print A and N. In the similar way, when I think A is greater, it should go to the as display of A and it should end it. And when I think A is not greater than B, it should go to as display 5 and N. Why after this I'm not writing anything means always I think my control moves from top to bottom in sequence. So whenever I want to move up and down, whenever I want to jump from one control to one statement to the another statement, I write my own statement that is moving or jumping from one step to another step. So this is how I make a decision. I jump from one step to another step, or I shift the control of the flow of the program. I shift the control of flow of the algorithm from a step to this step. That's what we call based on decisions, based on conditions. Our steps are going to be moved from one to another. So that's where the flowchart is representing here, moving of an algorithm from, that's algorithm possessing a key feature, that is a decision, not in sequence, decision feature. So here we move ahead with two or three more examples. What is an algorithm, to writing an algorithm and drawing the flowcharts to the algorithm, and write an algorithm to calculate the area of a rectangle. To make you to understand, as think that algorithm is going in sequence, one start and taking the input and calculating the area of the rectangle and displaying the area and stop, and all the steps are going in sequence, all the steps are going in sequence. And next, if at all you look at, write an algorithm to find the greatest of two numbers. The same algorithm which I've written previously, it has started, algorithm has started, and two inputs were taken, and I am checking if A is greater than B. If A is greater than B, go to 4. Which step it need to go? It need to 4. As if this statement is true, look at here clearly. If this statement is true, as this is going to the step number 4. If A is not greater than B, I'm asking it to go to 5. See here, go to 5. It moves from this step to directly this step, go to 5. And if after going to 4, what is 4? Display. After going to the 4, if A is greater than B, it goes to 4. And after going to the 4, if this step printing this, it need to move to 6. And fifth step is not going to be executed. Fifth step will not be executed. So move to 6 and displace A and move to 6. If this is not right, definitely it comes back to from here, it comes back to here, and after printing again it goes in sequence. So my algorithm here, if at all you look at this algorithm, is going in sequence, but even in going in sequence it is following some predefined order. When shifting the control from this step to this step if required, and shifting the control or the statements from this step to this step if required, and this is how my algorithm is going ahead, taking the flow based on the decisions. This is one algorithm, for example, to show that algorithms exhibit three features, any one of the three features or three features together. And write an algorithm to print the numbers from 1 to 5. Take this an example as, look at the algorithm. Start start I My aim is to print the numbers from 1 to 5. 1 to 5. I'm not going to write print 1, print 2, print 3, print 4, print 5, because 5 steps I need to write to print 5 numbers. Think that if at all I ask you to write an algorithm to print 100 numbers, do you write 100 steps to print 100 numbers? Print 1, print 2, print 3, print 4, print 5, print 100? No, it is not possible. It's very complex task. It is a tedious task. So what I need to do is I need any one of my steps, some step in my algorithm need to be repeated to get a solution. That's where the logic I develop. That's what the logic I develop. So what is that logic? The logic is here. You can look at the logic. Start and a equal to 0. I made an input and that input is equal to 0. Then I said a equal to a plus 1. I made the a value is 1. I can go for explaining you here. Now initially a value is 0. When I said here a plus 1, my a value has become 1. Look at a value has become 1. Then I said after moving to the fourth step, print a. I'll write the output here, output of the program, output of the algorithm, and output it prints 1. What it prints first? It prints 1. After printing 1, it is going to the next step. Which is the next step? Fifth step is the next step. Go to 3, where it should go until condition. I have written one condition. What is the condition? Until a is less than 5. Does a is less than 5? Yes. Why? Because a value is only 1. Look at here, a value is only 1. A has 1, a value is 1, so a is 1 is less than 5. Yes, so when 1 is less than 5, where it should go? My control, it need go to again step number 3. See, I'm moving back to step number 3. I'm not going back in sequence to the step number 6. I'm moving back to step number 3. What is step number 3? As a equal to a plus 1. What is my a value previously? Here you look at my a value is 1. So to 1, 1 is added. So what the a value has become? 2. Now my a value has become 2 and I'm asking print a. What is a now? A is 2. I'll get an output 2. And after getting an output 2, again it goes in sequence. Always when we are not shifting, we are not making the control to shift one step to another step. Always it goes in sequence. It goes to the next step. When it goes to the next step, again it is checked. Go to 3 until a is less than 5. Whether 2 is less than 5? Yes, 2 is less than 5. Again it goes back to the third step. What is third step? A is equals to a plus 1. What is a previously? 2 plus 1. Now it becomes 3. You can see now a has become 3. And next goes to the next step. What is the next step? That is print a. What is print a? 3. Now I get an answer 3, output as 3. And after printing 3, again it goes to the step 5. Go to 3 until a is less than 5. A is 3, 3 is less than 5. It is true. Then again goes to the third step. When it moves to the third step and a is equals to a plus 1. What is a? A is 3, but plus 1. Now it becomes a becomes 4. A becomes 4. And after becoming A4, it prints A. What is A? That is 4. And after printing 4, again it goes to step 5. What is step 5? As long as A is less than 5, as go to move to step number 3. We go to step number 3, and what is step number 3? A is equals to a plus 1. When a plus 1, 4 plus 1, 5. 4 plus 1, 5. When a has become 5, it prints 5. Now the a value is 5. When a is 5, print a. And after printing a, 5 is printed and going to the fifth step. What is fifth step? Go to 3 until a is less than 5. Does 5 is less than 5? No, 5 is equal to 5. 5 is not less than 5. So this is not true. This is not true. It has become false. So immediately it goes to the next step. What is next step? Stop of algorithm. End of an algorithm. So end of an algorithm, I got the answer 1 2 3 4 5. So I repeated. Here you can see these are the three steps which are repeated for 5 number of times. They are the three steps: step 3, step 4, step 5, step 3, step 4, step 5. They are repeated until my condition has become false, until my condition has not satisfied. Till then, these steps, some of these steps are a single step of my algorithm is going on repeated. So what the features we have seen as a part of the algorithms, they are algorithm moving in sequence, algorithm moving based on condition, algorithm moving as algorithm moving, going, repeating some steps again and again. This is where I see my algorithm going in sequence. This is where I see algorithm going based on a condition. This is where I see algorithm as in which the sum of the steps are a single step is repeated for a required number of times or a defined number of times by the programmer or the user. So that's where I mentioned the algorithm exhibiting the key feature, that is a sequence, and algorithm exhibiting the feature, that is a selection or the decision based moving, and the algorithm going with repetition of some steps of the algorithm. So these are the key features which the algorithm and even the flow charts exhibit. So for the same algorithms, here I go for showing you the flow charts. Flowcharts are being shown here. This for the same algorithms. This is where the algorithm of sequence for finding the area of a rectangle, and this is where the algorithm for getting the biggest of two numbers based on the condition is. And this is the flow chart which is being depicting printing of numbers 1 to 5, where some steps or one or two steps of the algorithm are repeated for a required number of times to get the solution. You can go for seeing here the condition is a is less than 5. Again my control is going to move back to the step number 3 here, and if it is not less than 5, immediately it goes to end. And so this is how the flow of the problem can be visually depicted or graphically shown using the flowcharts. So making use of the flowcharts helps us to understand the problems easily when compared to the algorithms. But we always need to write an algorithm and draw a flowchart when we go for finding a solution to any of the problems before we start writing code in programming language, because it helps a lot to understand the logic. It helps us a lot to know what exactly we are doing to get the solution to a problem. So that's where the algorithms and the flowcharts play a vital role and helps the programmers to develop logic, more precise logic to get the solutions. Okay. So flowchart moving in sequence, flowchart moving in selection or a condition based, and the flowchart repeating a number of steps. And one important thing I forgot to tell you, you might to remember one thing. These are the arrow symbols or the arrow lines which are representing how my program or the flowchart is going on. So here this is the step started, and next it has gone to the next step. After coming here, if this is true, it is going this side. If it is false, going this side. And these are the arrow lines as how program or the flowchart is moving is shown or depicted. Flow lines are the arrow lines. Okay, thank you all. Now we just go for seeing drawing a flowchart using the tool Raptor for one or two problems. Then we'll end up the algorithm, pseudocode, and flowchart session. Yeah, this is a Raptor tool which is used to draw the flowcharts. which depicts of our algorithms in a graphical symbol to make us to understand very easily how the problem is getting a solution. So making use of the Raptor tool, we draw the flowcharts to all our problems. And when you open the Raptor tool or the Raptor application, you find on the top, you find the menu bar, a title bar, a menu bar. Down it, we find the tools. And towards the left side, we have the symbol box where we have the symbols for assignment, that is operations, what we do in the flowcharts. And next, we have the input, output, and we have a selection condition based or the selection based symbol, and we have the repetition symbol here, that what we call it is a loop is nothing but repeating a step for n number of times or a predefined number of times, we call it as a loop. So I show you a basic example with drawing a flowchart. So here, if at all you look at the flowchart, whenever you open a new file in a flowchart, immediately it gives you two symbols already on the workspace, and this is called as the workspace. This is the workspace, and in the workspace you have the two symbols which already been defaultly available. One is start and end. It indicates that whatever you are supposed to do or add the symbols, they need to be only in between start and end. So for adding of two numbers, I'll show it basically adding of two numbers and greatest of two numbers. Then later on, you can go for working, taking the example, how the input can be given and how the output can be given by the flowchart to the user. So start, and in between start and end, you are supposed to add the symbols whichever you want to add. So I want to add my program, my flowchart is going to be addition of two numbers starting. Then I go for I need two inputs to add. So I need to take two input boxes to add. And here is the input box. You can look over here and see here. And this input box, click on it and bring your pointer in between the start and end. And then click immediately, you'll get the input box placed over here. And once the input box is placed, right click, placing your mouse pointer on the input box and say edit. And say edit. Once once you got the edit option, and immediately you'll be getting a window on your screen. Is it visible? Okay, is the screen is visible? Okay, once you get the edit, click on it, right click. Once you get the input box, and in the input box enter the prompt. So what the prompt you want to give to the user when you are displaying the algorithm, or when you are just executing the flowchart, that input need to be written over here. So prompt here, for example, I want to write enter a value, I'll write enter a value, because I'm thinking that I go for taking two values A and B, and that need to be written only within inverted commas, double quotes. And what the symbol you are going to use, whether it is A or L or B or X, that symbol need to be specified down here. Enter a variable here and then say okay. Why? Before I go for saying it, it is asking me to save the file. So I go for saving my Raptor file in the name of add.rap. Okay, I'm saying it add.rap, and I save the file and then say okay. Immediately you can go for seeing I got enter a value, and it is giving displaying get a. So my flowchart is asking the symbol to get a value from the user, that is a value from the user. So I'm going to give an input a, and then again I need one more input. Click on it and same process, right click, you'll get the edit box, and what the value you want to enter to make sure that to have a prompt for you, to have a clear idea from your side, write enter b value or enter b value. I'm writing enter B value, and that should be written only in inverted commas. Make sure it should be written in inverted commas. So entering b value, and which letter or the variable to which symbol that value need to be assigned, and that symbol need to be mentioned over here, and I'm mentioning it is a capital B and B, and say okay. And now I got the prompt in the input box, enter B value and get B. So it is asking me to enter B value. The system takes, or the flowchart takes, B value. And after giving A and B value, I need to find or compute or calculate the addition of two numbers. Addition of two numbers. To calculate that, I have the assignment. Yes, this is symbol, assignment symbol, or the process symbol. We call it as a process symbol or the assignment symbol. Coming to the assignment symbol, take and place it in between the end and the previous input box, and right click and say edit. Then what I am supposed to do, I need to add two numbers. So those two numbers addition need to be stored to some other symbol, some other variable, and that I am saying, maybe I'll say here sum. Set sum. I'm setting sum. So what is sum? Sum equal to A plus B. I have written A plus B. Done. If at all you see, you can immediately you can go for knowing something as the box is displaying sum is equals to A plus B. Then after calculation is done, computation is done using the process or the assignment box, then I need to give the output to the user. For giving the output to the user, I have an output symbol here. Take that output symbol and click it in between the assignment symbol and the output symbol. You get the output symbol showing the arrow out, in and out. You can have a difference over there, and click right click and then get it. And what the output you want? I want some need to be output, so I can go for writing some, exactly what the way you have written there, you need to write some, as I want some to be written over there. See, put sum, immediately it is giving the sum. So my flow chart has completed for adding of two numbers. That is, I'm taking an input A, I'm taking an input B, and my flow chart is calculating A plus B, and then it gives the sum and ends. My flow chart has come to end. Drawing of the flow chart or depicting my algorithm using a flow chart is completed. Now I need to make this flow chart execute. So for the execution, on the toolbar you have the buttons. Look at this. This is the run button or the execution button to complete the execution of your flowchart, and this is the next button. You can stop your execution in between, and this is the stop button to stop it, and next is a step-by-step execution of your flowchart. So initially I go for showing you step by step. When I click on the step-by-step execution of the flowchart, immediately your first symbol gets into green colored. The symbol gets into green turn, that means my flowchart is ready to execute. Then I click next, immediately it goes to the next box, that is in sequence it is going enter a value. When I click enter, now enter a value, it is asking me to enter a value. I'm going to enter value 100. When I entered 100 and say okay, immediately towards the left side you can see there is a as box down the symbols where it is showing what I entered in the first input, that is A as 100. It is a variable display box or the value working space display box. Okay, A as 100. So then when I click next, immediately it has moved to the next box, get B. Then I click next and immediately it asks me to enter B value. I'm going to enter the B value. I entered B, and immediately towards the left hand side you can see B as 200. 200, and then it moved to the calculation part or the computation part, sum. Now click next, immediately it has given sum is 300, but still the output has not given to the user. And when you say put sum and click next, and it has come to the end, when I say next, then my problem or the my flow chart gives me an output in a master console window called as an output window. You can see answer is 300, A is given as 100 and B is given as 200, and the sum is 300, output is given as 300, and run of the flow chart is complete. The number of symbols I used is 6, and 6 are evaluated, and my answer I got it as 300. And here I'll make you one more small change in the same flowchart. Instead of simply putting here only the value, I just go for making a change here. I want the sum of, as the sum is, I want to write the sum is, I'll go for writing the sum is, and that should be written within the inverted comma. See here, look at here, the sum of two numbers is within inverted commas. I have written sum, and definitely after that I want what that sum is. To get it, we use a plus symbol, what we call is a concatenation symbol of the strings, as use plus symbol and say it done. Immediately on the screen you can go for saying put the sum of two numbers is sum. Again I go for executing the problem, starts with start and goes to the next and asks me a value 500. Then I say enter. Immediately it asks me to enter the next value, then I say 300. Then it immediately it goes to the calculation part, and the calculation is done. As soon as I press the next button, calculation is done, 800 is displayed over here. Now I want the output to be displayed on the screen. You can see here the sum of two numbers is 800, and run completed, and 6 symbols evaluated for executing my problem as a flow chart. Okay, done. So this is how we go for drawing the flow charts. And I go for making you to draw one more flow chart and show you. Later on, you can go for drawing the flow chart for all the problems in the Raptor tool. And one more example, what I am going to show is using of a decision symbol. And that decision symbol is to make you to understand whether A is great or B is great. Only the basic problem. So let's go for taking one more new start. Now to decide which variable or which symbol is greater or which symbol is smaller, I just go for making it A is great. Print the greatest of two numbers. Print the greatest of two numbers. What I say is I want input. Take the input. What is the input I need? I need one value. Enter A. Since I'm making it very simpler. Enter A, done. Then I want, I'll take B value, enter B, enter B. Then I need to say greatest of this A is great or B is great. Which one is great? So I need to have a decision, that where I go for taking a selection box, make it here selection. See here, I'm writing the condition, edit. What is that condition? A, it's A greater than B. A greater than B. A is greater than B. If A is greater than B, what it need to do? It should print A. If A is greater than B, it should print A. So I need an output. So I go for taking an output where I need to insert an output between end and yes. Between end and yes. So I click here. So I get output. I'll say if what is this? I'll say A is great. A is great. That's it. And I'm saying A is great. And in case A is not greater than B, if this is not, I'll say I'll give a 10 rupees to you and I'll ask you to go to a shop and I'll ask if a chocolate is equal to 10 rupees, buy that chocolate. Otherwise, go for purchasing another chocolate. It is a condition. I have an X chocolate and Y chocolate. I'll give you 10 rupees. If X chocolate cost is 10 rupees, you buy X chocolate. If X chocolate cost is not 10 rupees, buy another chocolate. So same here, if A is greater, it prints A is greater. Otherwise, the other B is greater. B is great. So next, what I need an input if this is not true. So sorry, output. So take the output box and that output need to be in between end and condition. So again, I just right click on it and say B is great. B is great. Done. Now the flowchart is completed to find the greatest of two numbers. Sorry. Then execute it step by step. Start it, and next it will ask to enter A. I am entering A as 12. Okay, then it goes for the next symbol and it will ask to enter B. I'll enter 20 as B, B as 20. Then it is gone for the condition. Now the condition is going to be verified or checked, and immediately it is going to the B side. See, I entered A as 12 and B as 20. So which is great? A is great or B is great? Immediately it is saying B is great. So B, and it has gone to the B side and the value is going to be N, and I get an answer B is great. I get an answer B is great, and run complete six symbols evaluated. Once again, I run the same flowchart starting from the first, and I give A as 100 and B, and I give B as 99. Okay, and then the condition is going to be checked, which is greater. Then I and clicked next. Immediately it has moved to A, that is A is greater than B. It has moved to the A side, and now it will print me an output that B A is great. You can see is A is great, and run complete six symbols evaluated. And this is how we go for making use of the Raptor tool to execute our flow charts in a pictorial way or a graphical representation. And that's all for now. To know what is an algorithm, what is a flow chart, and what is a pseudocode, and how do we run and execute, draw and execute the flow charts making use of the Raptor tool. Okay. So see you in the next session, starting with the introduction of the C. Okay, we'll have a 2 minute or 3 minute break. We'll see you very soon with introduction of C.